Good afternoon, everyone, or good evening, whatever situation you're in. Thank you very much for tuning in and taking the time to expand your horizons and to learn a little bit. So, my name's Jack Griffin, and if I've met you before, welcome back. If I haven't, thank you for tuning in. My job is to take a little bit of time and create some interest in some of the things that we do on a day-to-day basis, help you become a better clinician, and also let's do some entertaining stuff a little bit. So slow down to speed up, a little play on words, of course. The thing is that, well, the last couple of years has been a strange time with COVID and all. I mean, it really has made a lot of us stop and reevaluate life even. And of course, dentistry, we're all dental nerds, and whatever we do in life affects dentistry for us, and whatever we do in dentistry affects life for us. And I think slowing down and just relaxing and learning and enjoy the ride. I think that if there's been any positive part to the pandemic, the last couple of years, some of us have just taken a little bit more time to learn to relax and just enjoy things a little bit more. So I am talking to you today from Las Vegas. I am from St. Louis, but these pictures are from Iceland. So my job is to keep things from getting confusing and to make sure that I don't lose anyone here. So I don't want to waste your time. I want to make sure that this is productive. That is Iceland. My wife and I got to do a little trip over there, and we did a series of lectures over there. And it was truly fantastic. And the reason really that it was fantastic is it was so much different than any place you've ever been if you haven't been there. If the weather's good, and that's a big if, it is a fantastic place to slow down and just enjoy the world, just enjoy the creation of the earth. This is looking from a tunnel, an ice cave, if you will. And if you look at the sides of the walls, you'll notice there's some clear areas and then some black stripes and then some more clear and a littler black stripe and a bigger black stripe. And so those are lines of time where the blackness is the eruptions of the volcanoes in Iceland. And then, of course, the clear things are the there were periods where it didn't erupt so much and not as much volcanic ash, and then it would freeze and glaciers would form. And anyway, so follow the science. You've heard that a lot these days. We're going to talk a little bit about that today and where we're going with science and dentistry. But that's the cave I took those pictures from the inside. Of course, the glaciers are melting and all that, and I'm not going to get into environmental things with you. But I will say this, is that once you go and see and look for yourselves, that you get an appreciation for the earth. Let's just put it that way. It is a beautiful, fantastic place. And anyway, just wanted to share that with you for today. If we could talk about better bonding, better adhesion, then we'll all be better dentists. Less stress, less failure, less sensitivity. Number 2, steps and timings to become better at adhesion. I don't want to make this a boring science lesson, so I won't do that to you. Well, I want to reduce the failure, reduce the breakage, and get rid of some of the sensitivity you have in your office. I'm not a magician. I won't make every restoration last forever and be perfect. That's impossible. But I just want to reduce the failure, reduce the issues so that you have more clinical success and less stress. So there you go. There's the outline for today. Right now, I'm not important, but what I will say about myself is that I've practiced for over 30 years. I've done a whole bunch of lectures, written a bunch of articles, and the last couple of years I've done a whole bunch of webinars. And I will tell you that despite the fact that some of you, well, I'm homely looking and I have bad hair. So if you were teaching, you wouldn't want to see me in person, but I do miss seeing you. So if I had a chance to be in a room with you and look at you and talk to you, I think I relate better. That said, thank you for doing these webinars and putting your time into learning. I want to thank our sponsor, who is Bisco. Trust me, this will not turn into a commercial, but we're going to talk a little bit about science and why we do what we do. And Viva for doing all these great courses and stuff. It just seems like yesterday we started 2021, and now we're well into 2022 now. It's getting late February. We're heading towards the next year. Have we reached 2 weeks to slow the spread yet? That was back in 2020. I don't know. 2022, let's make it a great year, a prosperous one for you. But more importantly, I want you to learn to slow down, do better dentistry, and enjoy life more. With today's dental entrepreneurship, multiple practice, DSO world that we live in, there is more pressure on the doctors. I talk to many of you every week. There is more stress in dentistry now than ever. And mainly it's because of two big reasons that I can see, and that is debt. A lot of the young graduates coming out with so much debt. And the next reason is the environment in which we practice, putting stress on us to produce more with less failure. In other words, we've got to crank it out and have totally happy patients that never leave a bad review on the internet. Well, I got news for you. Dentistry is far from perfect. I've never done a perfect restoration. I've never done a perfect cosmetic case. I've never done a perfect anything. I can tell you this, though, that I've tried as hard as I can to do as well as I can. When we see failure in the practices, by the way, I have practiced private practice fee for service for 20 something years. And then I kind of retired, and then I bought some practices, and I was in that DSO world as an owner and a clinician for several years. So I will tell you that I have a preference for which one of those is better for you as a practitioner. But I will say this: if you do better dentistry, no matter what side of the equation you're on, better dentistry means more clinical success and less stress for you. And that's what it's about. I looked at Bentley, our chocolate lab, and said, buddy, you're getting fixed. And he said, I'm not broken. Why am I getting fixed? Anyway, we got him fixed anyway. And there's this cone of shame. So I want to get rid of that cone of shame that we have whenever a patient walks in with a crown in their hand that we just cemented 2 weeks ago, or they walk in carrying a crown and it's got our post that we just put in the tooth. The crown and the post are still together. So that worked. It's just that none of it stuck to the tooth. Or a patient comes in and says they're sensitive. They can't chew. They can't floss. They can't drink cold after we just did a filling. What did we do wrong? So again, if we could just take a little bit of the stress out by getting our clinical techniques correct, then this will be worth my time. So just a few little things. Two major areas of stress for the doctor. Number one is the schedule. And that is that we all feel the ticking of the clock. If we are behind, we feel that stress. We don't like it. And so none of us like being behind. Number two, clinical failure. So if we could get rid of those two issues, then we would have a stress-free, awesome practice, right? Well, except the staff, of course. We won't get into that. So again, science has changed the way we look at things with time. And so let's go over some of the basic stuff, some of the things that are working right now. And what I can share with you is just from clinical experience, doing a little bit of research. And I do have the opportunity to spend some time with some manufacturers and looking at new materials and things that are coming out soon. That there's some exciting things happening in dentistry. Let's just put it that way. It's a great time to be a young dentist. Let me give you one little bit of advice. Slow down, relax, enjoy the ride. I know you probably work in a clinic and you have to schedule crazily to produce or meet your numbers. I got that. You got to please the boss. I want you to make a good living, right? But for your sake, slow down. Let's talk about that clinically speaking. In Iceland, so that's a volcano in the background. I don't remember the name of it. When they make words, they use a lot of J's and H's and put them all together. And I don't even know. I don't have a clue how they form those words. They kind of all look the same after a while. But the glaciers, what's a glacier? What's a mountain? Well, a glacier is a ice structure or a mountain that's moving under its own weight. So its own weight causes it to move. That's the difference between a glacier and a mountain. So again, melting glaciers, and sure, they refreeze back sometimes, and but with time they are going down. It's easy when you go over there and look, and you see pictures from what it looked like decades ago and all that. Now, I'm not here, I'm not an environmentalist. I'm not going to talk to you about that stuff, but I do think the Earth is a beautiful place. I want to do what we can to preserve it. So if you look in the background, that's a glacier. You see the ice way back there, and it's melting into that stream there. Again, that was normal for the time of the year we were there. Some parts of Iceland look like the moon. I mean, if I knew what the moon looked like, volcanic stuff and nothing growing all over the place. So it just surreal. And like I said, if the weather's good, it is a beautiful place. Okay, science. When you look at the striations of a glacier, you see again, from a different angle, whites and blacks here, with different degrees of grays in there. And those are different times that the scientists tell us that the volcanoes erupted, and then ash became embedded in the snow. It compacted with time and pressure and formed those little layers. And those little layers represent many hundreds and thousands of years. And so as they melt, we get a cross section of the Earth, if you will, kind of a core, if you will. And I took this picture, if you notice. We're with a tour, and this light is kind of shining through the ice. Do you see there in the center of the picture? And then to the left edge of that ice structure, there's a nose and eyes and a mouth. And I know it's my mom yelling at me for something. I can just see her face there. I love my mom, but I can just hear her yelling at me. But anyway, there is a face in that cliff. I'm sure it's there, right? Is that not a face? Can you not see that? Anyway, when we look at bonding, some of us see things that others don't see. I want you to see a couple of things that are very clear that we can all identify. First of all, universal bonding agents are a category of bonding agents that are here to stay, at least for the time being. The research is heading towards restorations that may bond themselves in. And I've even written some things on some of these materials. We're not there yet. Let me just warn you right now that the best long-term, most stable bond is still using bonding agents. The best category of bonding agents for what most of us clinicians do every day, and that is direct restorations and indirect restorations. The best category of bonding agents to be in are what we call universal bonding agents. And there's 100 of them on the market, I swear. A lot of them are good. Some have better qualities than others, but I'll go over some of that stuff with you. Let's talk about the science a little bit, if you will. Universal. What does it mean? I've been talking about this for years. Universal sounds like that you should be able to use it anywhere, anytime you want. That is not what universal means. Universal means regardless of your etch technique, they work well. In other words, whether you're total etch people, never etch anything, or do what many of the clinician research type people do, including myself, we do selective etch. In other words, the best bond in the history of dentistry right now is to phosphoric acid etched enamel. The best long-term bond to dentin is to unetched phosphoric acid etched dentin. So in other words, we want to etch the enamel and not remove the smear layer from the dentin. That gives us the best combination of bond strength long-term and sensitivity control. I know you know that already, and this is all review. Let's get to some stuff that isn't. The universal dentin bonding agents as a category are very tolerant, whether your prep is too wet, too dry, but we prefer moist. In other words, just a little water there. Dentin is water-based, and we've got to keep water on the dentin for it to work. We'll get into that. Universal dentin bonding agents are very versatile, whether you etch, no etch, but we prefer selective etch. These have a very good bond to almost everything we use in dentistry, particularly for you and me, enamel, dentin, zirconia, and ceramics, because those are the things we use the most. It's been a rapid switch to universal adhesives over the last 10 years. Over 8 out of 10 of us use these already. So I'm not here to sell you on universal bonding agents. I'm here to tell you that you're in the right category, most likely. If you're not, and if you're one of those people that come up to me at a meeting and say, Dr. Griffin, well, people mistake me for John Coyce. I get that all the time. I know that's just because we're so smart and stuff, right? Maybe it's the hair. Regardless, I'm on I use generation 7 bonding agents, or I like third generation bonding agents. Just because you know the number of your bonding agents, I think that's very nice and that's fun at parties and stuff, but it doesn't really impress me that much. Here's what I want you to know. Can you use your bonding agent on almost all the dental materials we have in today's world? Number 2, can you use it on dentin that has been etched or non-etched? Keep that in mind for just a minute. We'll go over that in a minute. When we look at a lot of the bonding agents on the market, the first thing that we notice is characteristics like color and film thickness. How thick is the stuff? Does it cover the tooth well? Does it dissipate well when I blow air at it? So here's 2 popular ones. All Bond You on the left, not as yellow and not as thick. And on the right, the Scotch Bond is definitely more viscous, a little bit yellower. And if you use Scotch Bond, you know what I'm talking about. So when I ask you about this, you know this picture backwards and forwards, selective, total etch, and self-etch. When self-etched adhesives came out many years ago, we started playing with products like Curare's I'm drawing a blank. Can you believe it? I'm in Las Vegas. Can you believe that? I can't think. So we were total etching everything for years, like in the 80s and 90s, and we had a lot of sensitivity. And then we went to no etch. And when Clearfill came out, we got rid of the etch. We thought so. We reduced sensitivity. Yeah, we did, but we didn't make restorations that lasted very long because on unetched, uncut enamel, they didn't etch the enamel well. So long story short, selective etch is where we are today. Best bond to enamel, best long-term, less sensitive, durable bond to dentin. What I want you to know science-wise, so as a normal dentist, you got all that stuff. I know you do. Let's go beyond the average dentist. Let's talk a little bit more about what I'm here for, and that is to do a little bit of science with you. Follow the science. You see it on CNN or Fox every night, right? Follow the science. Universal dentin bonding agents are acids. They are acid. When you put a universal dentin bonding agent on a tooth, they etch the enamel somewhat. And because they're acidic, they modify the smear layer on the dentin somewhat. The degree of acidity matters. How long it stays an acid matters, because if you had an acid on a tooth forever, the pulp would not like that. So how alkaline it is, how acidic it is, and other factors like the water content and all that, those are all important. We're not going to go over this boring junk with you, but you'll see on that list, there's a bunch of bonding agents. Probably the one you use is on that list. These are very good ones. I'm going to give you some studies now, and I'm not going to read them to you. If you want the studies and want to check out my research, go to the bottom right of each of these slides. I have the article that summarizes what I'm talking about. Those are clinical reviews or research reviews. That's the best way to kind of see where the preponderance of evidence is going these days in the research. So anyway, you can go to PubMed or some of the other government sites, and you can get all the articles you want, or at least the summaries. If you look on this scale to the left, there's ultra mild bonding agents, universal bonding agents. There's mild bonding and intermediately strong dentin bonding agents. So look at the bottom of the page first. You see Peak down there, which is a good bonding agent. It's got an acidity of 1.2 pH, very high. If you go to the top of the page, ultra mild, where All Bond You is, it says 3.2 pH, and there's a bunch in between. What does it matter? How does it matter? Let's put it like this, that the more acidic your bonding agent is, the more likely you are to etch enamel and not have to rely so much on the phosphoric acid etching your enamel for you. However, that strength of the bonding agent's acidity may affect your long-term bond to your dentin. I'll go over that. So that's kind of where we're heading here. A different graph from a different article. Look at this one. Classifications: mild, ultra mild, mild, low, mild. You see that going down the list. Different bonding agents. What gives the bonding agents their mojo? What's in them that works? So with any company that I've consulted with or talked to, pretty much you can copy just about anybody's formula with a little bit of time and a few machines in the lab. But what really is working today? There's a couple of things I want you to know that's in all of your bonding agents. There's water, of course, and there's some ethanol or some sort of carrier like acetone. Water, acetone, and ethanol are in almost all of them, one or the other or two of the three. But notice there's HEMA in many of these. There's HEMA not in some of them. There's bis-GMA. There are other big $5 words in there. Here's what I want you to focus on for this lecture is 10-MDP. An old word, an old group of letters that y'all know, you've heard it before, 10-MDP. That's where we're at today. Let's just summarize and not even think about the rest of the stuff that's in there to some degree. 10-MDP is where it's at. Whatever dentin bonding agent you use, make sure it has 10-MDP in it. If you were to say someday see a test question on what are the key ingredients to bonding in today's dentin world, I think 10-MDP would be a good place to start. But the acidity matters. Here's the summary of the research. Durability of dentin adhesion has been shown to be less for those universal bonding agents that are more acidic. Remember, I told you just a second ago that how durable, how the quality of your bond to dentin depends upon the pH of the material. The lower the pH, higher acidity, lower long-term bond, because the collagen fibrils don't stay in good shape long enough to hang on to that bond, if you will. The second little paragraph there, after light curing, there remains some unpolymerized monomers, which may continue to demineralize the dentin. In other words, we normally, when you put a universal dentin bonding agent on the tooth and you air thin it, then you shine your light at it. When you shine your light, it's supposed to stop the demineralization, stop the acidity from continuing. It's supposed to do that. But the more acidic your bonding agent is, the more it continues to demineralize the collagen, the dentin, after you cure the light. So when you have a more acidic dentin bonding agent, it creates an unstable collagen environment. So again, acidity matters. Again, so kind of in review, look, again, so I said that there's different pHs of universal bonding agents. They're all acids. We want to strive towards universal dentin bonding agents that are less acidic and rely on the acidity of our phosphoric acid to etch our enamel. And then on our dentin bonding agent, on the dentin part, we want to modify the smear layer with a weaker acid so that our bond stays more luxurious longer. Luxurious? I don't know if that's a scientific word, but regardless, you get what I'm saying, I think. So pH matters, but we want to pick things that maybe aren't so acidic if we're concerned about longevity and sensitivity. Universal dentin bonding agents, technique matters. So this lecture, slow down to be a better dentist. We started talking about Icelandol, about science. Can you believe it? There are 4 things that are extremely important in bonding. And if you get the opportunity to go to a lab and play with different bonding agents, different techniques, you will prove to yourself very quickly that these 4 things are very easily proven to be very important, but we all skip these because remember we started out by saying the stress of dentistry often is the ticking of the clock and we're behind. We don't want to sit there and wait for something to cure or wait for multiple coats or wait for stuff to work. We want instantaneous results. That might not work so well. Technique matters. There's 4 things here. Keep your tooth moist, scrub, multiple coats, and slow down. Okay, let's take a look at those one at a time. There's science to back all of these. The bond to enamel is significantly better if you use phosphoric acid etching. Okay, so that's clear and easily understandable, right? Universal dentin bonding agents that are mildly acidic give us a better long-term bond to the dentin, though. So let's continue to phosphoric acid etch, 34, 35, 36, 37% phosphoric acid on the enamel, 10 to 15 seconds, rinse, leave the tooth moist. Okay, there's a summary of some stuff so far. The dentin smear layer, we would like to keep on there as much as possible. But I always ask this. Now, I'm a little nervous at work, maybe too much coffee or something. Can I keep my etch only on the enamel? Or are you like me? You slop a little bit on the dentin. Unintentionally, you etch enamel. You intentionally etch enamel, but then you unintentionally etch a little bit of dentin with it, right? So when you rinse off your etch, you've got etched phosphoric acid, which you planned on, and you've got some unetched dentin, which you planned on, but there's a little bit of dentin you slop some etch on that's unetched. So will your dentin bonding agent work to unetched dentin and etched dentin? In other words, you got a bonding agent that is versatile enough to do both, and that's where the universal bonding agents come in. If you're using your dentin bonding agent without phosphoric acid etch, you must wait 30 to 60 seconds before you air thin or cure. Let me say it again. Let's say you're just a non-etcher. You hate phosphoric acid etch. No matter what, you're not using it, period. So if you read the instructions, which I know that most of you have not done because the print is too small, even with 4.5 magnification. So you can't read it, right? That's our excuse. Almost all of your instructions with a self-etch bonding agent say to wait 30 to 60 seconds, applying multiple coats while you wait. Do you do that? That's my first question to you. It's faster to etch, rinse, and then apply the bonding agent than it is to follow the instructions in a self-etch mode of a bonding agent. In other words, you self-etchers, some of you say you don't use phosphoric acid because it's an extra step and too much time. I'm here to tell you that that's exactly not right. If you read your instructions, it takes the same time, maybe slightly longer than using etch. Acidity matters, it always matters. So that's the point I've tried to get across to you so far. Now, when you do a total etch technique, you're relying on micromechanical retention. When you remove the smear layer after total etching dentin, you open yourself up to tubules being open or left open and then causing sensitivity. It's possible. It's possible, right? Some of you will say, well, you never have sensitivity. You've been total etching forever. Okay, then you got it figured out. Then don't change. Many of us, though, are looking for better long-term results and less of a chance of sensitivity. In self-etch mode, if you didn't use any bond etch at all, chemical adhesion is what you're relying on mostly. MDP, remember what we talked about, 10-MDP, a great place to start in bonding in this world today. It bonds to calcium to form salts. Whenever you don't use phosphoric acid on the dentin, you get collagen that is better apt to stand the rigors of time. In other words, your bond is more stable because of calcium salts if you don't use phosphoric acid on the dentin. Again, I'm just kind of building a case for why we do what we do. So in summary, enamel, best long-term bond if you phosphoric acid etch first. In dentin, best long-term bond if you don't phosphoric acid etch. So there you go with selective etch. That's why we're where we're at. Okay, so let's do some cases. So here's my dentistry, my own crummy dentistry, if you will. Not crummy, but I mean, whatever. It was early in the morning on this case. Remember, I haven't woken up yet. I have a couple of cups of coffee at this time. I have the patient in retractors. I have to grab my camera and take a photo for you all to look at. Here's what happened. Look at and I use great etch. My etch ran down onto the dentin a little bit. Look on that tooth number 27, that cuspid, you'll see etch on the enamel, which is where I intended, but you also see etch ran down on the dentin on that class 5 there. See, that's not supposed to be there. That wasn't my goal. Now, when I rinse that off, I'm going to have some areas that are etched on the dentin and some that aren't. Look at that. I'm just like messy. I'm sloppy. Maybe I was in a hurry. I don't know. Or maybe it's the fact that I just stopped to take a photo for you. No, it's just that we all do that. And so we need to use bonding agents that can bond to both of those worlds, intentionally etched or not etched. Now I'm talking about the dentin, of course. On the enamel, again, I've tried to make you a case already for bonding to etched enamel, because when you look at the SEMs of the cases, without boring you, you get more holes in phosphoric etched enamel than you do on self-etch enamel. It just looks better. You get more of those tags and just better. So I don't have to sell that to you. When you do self-etch on dentin, though, look at that nice collagen lattice work. It looks like little worms on the dentin on the right picture. We like that. Those are collagen thingies that are hanging on to our bond, if you will. We like that world better than the world on the left with the open dentin tubules. We don't want that world for 2 reasons. Number 1, potential for sensitivity. Number 2, the fact that with long term, we don't have stable collagen there. That may be an issue. Collagen's good. My wife brought this home, I noticed, and it's some sort of lotion. It says firming collagen body lotion. It firms and nourishes. Younger, firmer, who wouldn't? I mean, really? So collagen, like everybody knows about collagen. So we got to know about it too. Universal dentin bonding agents, technique matters. It's all about the collagen. That is the thing that we're worried about with dentin. The research is clear. Keep it moist. If you just happen to over dry it for whatever reason, then re-wet it. Yeah, I know. It's that question is what's wet, what's dry, what's moist. Okay, so if there's puddled water on it that you can see with your 3.0 loops, then get rid of that puddled water by suctioning it off, blotting it dry, or air thinning with a light touch. Some of you just stand, like when you drive your car, the pedal on the right is there to be pressed, right? So you press it hard. Well, some of you with the air water syringe, same thing. There's a button on there on the right to air things off, and you press it hard, just like you drive. Don't do that. Light pressure. Maybe move your air water syringe away from the tooth when you air dry it, or just blot it dry. It's all about the collagen. And when you keep the collagen moist, we get better penetration of our resins, better surface area of collagen to grab onto, better long-term bond, less sensitivity. Okay, back to the case. So you can see that my enamels, it's even frosty there a little bit. Hey, back in the day, we used to etch things for like 2 to 4 minutes. Yeah, serious. I mean, we etched the dentin, we etched the enamel, I etched my assistant, I etched the countertop, whatever came in the office, I etched. And then we would dry it off and look at the white frostiness. Now, we don't do that anymore. In this picture, because I had to stop and take a picture for you, notice my enamel is drying out. It's frosty. You don't have to see that. We don't need it to be frosty. We know it's frosty underneath the water, but we want the surface to be moist. We're going to do our selective etch, 10 to 15 seconds. Your enamel is going to be somewhat frosty, but you don't have to dry it to find out. Air thin the water. And what I mean is air thin the water. Don't blow it off the tooth. We're air thinning the water. Look, it's shiny still on the dentin. Apply your bonding agent. Dip and massage, dip and massage, dip and massage several times per tooth over a 20 to 30 second period. Now remember, I've already etched the enamel for 10 seconds. I rinsed it off. I air thin the water. Then I dip and massage, dip and massage, dip and massage, several dips per procedure, if you will, per quadrant, and I'm massaging the dentin. I'm working the bonding agent into the dancing collagen fibrils, if you will. Air thin your bonding agent, light cure it. In this restoration, I'm going to use nothing but flowable composites. So the aesthetics won't be like my board cases would be, but I'm going to put a little bonding agent. Excuse me, I'm going to put after I cure my bonding agent, a little flowable at the gingival margin, light cure that, and then I'll build up the rest of the tooth. In this case, it's all done with an injectable hybrid or a flowable composite. We could use something else and get a more opaque restoration that probably looks better, no doubt. My dad used to always say, my dad did a lot of carpentry work, measure twice and cut once. Agreed. No doubt, because I sure messed up a lot of things. I can still hear him yelling at me for things. If you cut something too short and try it in, like trim, and you go to try it in and it's cut short, well, it's already cut short. You already ruined it. Well, now in dentistry, we kind of got that similar situation going here. Once we put a restoration in and we blew some of the technique or didn't take as much time on the technique as we should have, we've kind of blown it already. But it's recoverable in a lot of cases. If you over dry the tooth, re-wet it, let the moisture sit on there for a few seconds, then put your bonding agent on. So again, if you're heavy-handed on the air, you just can't control it, you love the sound of blowing air on teeth, then re-wet it a little bit with a moist cotton sponge, a 2x2, whatever it is you use, because the research is clear on this. Over drying is bad. Dry enamel, moist dentin, that's preferable, but if your enamel's moist, your bonding agents today are somewhat hydrophilic. They work in a wet environment very well. 10 MDP is what bonding these days is based upon, and 10 MDP is a $10 word, at least for a Missouri guy. Those are too big of words to say. I will focus on the last word there, that 10 MD, the P word, phosphates. Phosphate's important. So in 10 MDP, the P stands for phosphate. Keep that in mind for just a minute. That's important. So the 10-MDP interacts with hydroxyapatite and it favors bond durability and strength today, right now, 2022, in today's world, even with some of the new materials getting ready to come out this year that you have not seen yet, that I know about, 10-MDP is still what good quality long-term bonding centers around. Make sure your materials have 10-MDP, your bonding agents, your primers, and your cements should have 10 MDP in them. Durability and strength. Phosphates, don't forget that word. Let's take a look at that. Here's 10 MDP. Now, on your test, you're going to be required in just a second to write down this chemical formula. I would like the lines and the little angles and all the equal signs to be in exactly the right place. And I'd like you to shade it from light to dark blue when you answer it. If not, I'll give you part credit maybe. Here's the key. We need phosphates. We got to bond. The phosphates are important. When we look at 10-MDP, we're bonding with calcium salts. And whenever we look at things that might interfere with our bonding, if there's phosphates already on the tooth, like maybe from blood or something, that might interfere with our bonding. I'm going to get back to that in just a second. Hold that idea for just a minute again. Look at that, memorize it. You'll be asked that in just a minute. If we look at 10-MDP and the way it bonds, it interacts by forming salts with the collagen. You're never going to be asked this. Don't worry about that. But my point is the P word. There's that little red balls on the right, phosphates. And by the way, disclaimer, I do have a scanning electron microscope in my garage. I bought it off of Amazon. I put in scanning electron microscope, and then I put, there's a little button that says buy now. So I just click buy now. That's what I got. So all my scans are done with this, and it was under 40 bucks. So everybody should have one. A 10-MDP, summarize, a functional acidic phosphate monomer. It etches the smear layer, and calcium released from HA forms salts with the 10-MDP. Okay, so it's a phosphate monomer. When you put your bonding agent on the tooth that's a little bit acidic. Remember, a mild acidity in your dentin bonding agent. It etches the spear layer, calcium's released, and it forms salts with a 10-MDP. This happens greater and faster on dentin and less so on enamel. After you air thin it and light cure it, that salt formation and acidity largely stops. Not totally, but it stops for the most part. That's what we want. Air thinning and light curing. Your instructions tell you to air thin and light cure. If you ever read them, they're going to be on there. Okay, the only reason you wouldn't light cure a bonding agent is if you had a dual cure bonding agent for some reason. If you did, you know about enamel and dentin. Dentin's got a lot of water in it. Enamel has little water in it. That's the only thing I want you to get out of this about the content of water. Make sure your adhesives match the standard. Here's the standard. An acid, but not the strongest acid you can get. It shouldn't be anywhere near one to me, because you get better results if it's a weaker acid. Low film thickness, under 10 microns, and whether you self or total or selective etch like we recommend, but especially if you intend to etch the enamel but accidentally slop some etch on the dentin, will your bonding agent still work to etched or unetched dentin? 10 MDP is what most of today's bonding is about. Almost all of long-term studies show us right now that 10 MDP is critical for the best bond in dentistry. You can find it in bonding agents, primers, and cements. So just please take a look at that. Make sure it's better. It's better by having it. If a little MDP is good, wouldn't a lot be better? Well, not so much. So there's got other stuff in there, of course, that matter. And all of that combined is a package. And that package makes a difference. We wouldn't want to have too much 10 MDP. That might change the chemistry in a different way, or we need enough water, enough acetone or ethanol, whatever the carrier is. So all I'm saying is this, is that whenever you look at your materials, look at the pH, and look at whether it has 10 MDP in it or not, again, follow the science. I'm just giving you a little bit of that. Technique matters. Point number 2, scrubbing. Yeah, none of us are scrubbers because it sounds too confrontational for dentists, like, because we're passive people, right? So like some of your instructions used to say agitate the dentin bonding agent onto the tooth. Agitation sounds mean. So we stayed away from that. Then a lot of the instructions changed to be politically correct, and they went to massage. Now that sounds more therapeutic, but we still don't do it, because massaging means I have to spend a few seconds doing something, and it actually takes muscle movement on my part. Well, I'm lazy by nature. I want it to be instant, and I don't want to have to massage anything. When you massage, though, dip and massage, continuously applying new product to the tooth. Now, here's what I'm talking about. The assistant puts out a drop or two into your well. You dip into that same drop and keep applying it over that 20 or 30-second period, massaging it in. The reason you do that is to work it deeper into the collagen. That's all. Okay, that's all. It just helps with infiltration. Now, of course, on the left, you get that little round, bally, tufty thing. And then on the right, more of a brushy thing. The one on the left probably scrubs a little bit better. And if you do research, I know we did this a couple of years ago on something, and the one on the left did slightly better than the one on the right. Depends how stiff and how long the bristles are. So yeah, there's some differences. So again, I've said it several times now, dip and massage, several times. Multiple coats is what matters. Here's the deal. Keep putting fresh material on that bond. The time that it's setting there will help make sure that your bond is as efficient as possible in its contact with the collagen. Multiple coats over a period, then air thin and dry. Slow down. Dip and massage, leave it on 20 to 30 seconds before you air thin and light cure. Slow down. Enjoy the ride. Massage a little bit. It's therapeutic. It sounds like something that we should all be taking part in every day. A little massage is a good thing. You're going to massage your dentin from now on, so it's going to sound almost romantic. to treat your dentin. You look at the tooth you're working on, you say, would you like a massage? And then you massage it. Now be careful. I don't want you to get in trouble, but massage. Read the directions, how much time before you air thin and light cure, probably in your instructions, depends upon how acidic your dentin bonding agent is. Most likely, your more acidic ones will give you a shorter waiting time than the less acidic bonding agent. So again, remember, they're all acids, but some are weaker acids than the others. Air thin, light cure, the etching and changing of the tooth largely stops after the light curing, but it still continues a bit. And the more acidic ones, it continues longer. Okay, smear layer. So basically, we're conquering the crud. We're dealing with dirt. So we got junk on the surface. What we're doing with a universal bonding agent is self-etch mode is we are conquering the crud. We are modifying the smear layer. By the way, we don't have much time left. I'm going to kind of get to some clinical cases, and that's about it. When we drill, we mess with the outermost layer of dentin. We leave a micron of junk. Dealing with dirt. It's a mixture of HA and collagen, bacteria, saliva, whatever else is on there. And time matters. And how we allow our bonding agent to modify that junk matters. Time matters. Relax. Let it work. When we have acids and water, there is something called hydrolysis, and I'm going to forget that for today. It's way too complicated for me. And I asked Siri about it last night, and Siri just said, huh, back to me. And so there's more or less acids and more or less hydrolysis. Let me explain it like this. The more acidic your dentin bonding agent, you've got hydrolysis things that happen different than less acidic. So what I'm saying is I've given you the pH stuff already. Let's not beat that to death. Technique matters. Keep moist, scrub, multiple coats, and slow her down. Learn to relax with time. Okay, so let's do a couple of cases and quit. Here's a tooth. Here's a restoration placed 2 years ago. Here's a failed restoration. Why did it fail? Okay, so probably wasn't the bonding agent. I'll give you that. It probably was a combination of other things. Isolate, new 330 burr, remove the old restoration, remove the decay in the adjacent tooth, look and see if there's decay in there. When we work on a tooth, the one thing that I will stress, that I always stress in every lecture, is don't be a cheapskate. When I went into the multiple practice world, I was really into numbers. It's funny, I practiced for over 25 years in private practice, fee for service, and I never worried about the numbers. They just happened. But when you own practices and you're the manager of practices, you look at all the numbers and every penny matters. And I used to think I was such a cheapskate. I got to reuse my burrs over and over. You know what? I can't afford to reuse burrs. Throw them away. Single-use burrs are the way to go. They're 90 cents to $1, depending on how many you buy at a time. Just get new ones. Less heat buildup, less irritation to the dentin, less pulpal trauma, and you've got a better situation in order to get a happy patient, less stress for you. What's the bond strength to dentin? Give up? Now, you know this, it's 0, right? So sometimes I can see dentin that's decayed because it looks different. That's what a lot of us do. Other times, though, you take a sharp, pokey thing like an Explorer or a spoon and you scrape or poke. I'm recommending not to do that. I mean, you can do that, no problem with that, but check yourself once in a while. A little caries indicator. It'll make you humble. You'll be amazed how often you leave decay in places you shouldn't have left decay. Now, denatured collagen is... so caries indicator doesn't stain bacteria, it stains denatured collagen and debris. So you look on the right, that might be a false positive on some of that. Some of that's probably decay where it's green, but it makes you look again. So false positive, I'm still going to get rid of that, but I'm not going to drill into the tooth, if you will. I'm just going to get rid of the green a little bit. But the decay that I left in there, I got to look at. So again, do you have to remove all the decay? That's for another lecture. And the answer is no. You just can't leave decay, that big, thick, mushy stuff in the middle of the tooth. And you can't have decay within a couple millimeters of the periphery. That's for another lecture. Remove the decay. In this case, I put a little liner in there. This is Theracal, a calcium silicate liner, light cure it. Then put my sectionals, wedge, and ring on. Burnish my sectionals. Selective etch, 10 to 15 seconds. Rinse, leave the tooth moist. Apply your Denton bonding agent. How wet is wet? Well, this is a classic picture that people look at all the time. On the left is the ocean. That's too wet. On the very far right, that's just sand. That's too dry. We want to shoot for the middle. That's my dog there. That's Bentley walking down the beach. Now, he's wearing a plaid handkerchief, and he thinks that the other dogs are making fun of him because he's wearing plaid. And I let him know that even though he's had the cone of shame and he's been fixed, that plaid still makes him look tough. And that's just all there is to it. So he is representing a collagen fibril. So that's Bentley as collagen. We want it to be moist. Remember, you can overcome that problem though just by putting a little more water on it if you over dry. Just don't get heavy-handed with the dryness. Problems with posterior composites are common with all of us: contact, shrinkage, depth of cure, sensitivity, longevity, and time. But let me stress to you, slow down. That extra 30 to 60 seconds that you spend doing these bonding techniques, if you will save you many, many hours of time over the year in redoing, adjusting, and having to counteract those negative reviews about you on the internet. Predictable contacts are done with rings, and I'm going to kind of skip through this a little bit here, and let's go on to something else here. So when we talk about water and stuff, the one thing I do want to stress to you is that when you look at your tooth and it's not shiny, to put a little water on it, then your bonding agent. Your bonding agents work well in a moist environment, and don't think that you're putting too much water on unless it's puddled in there. When you dip and massage, you will dissipate some of that water. You know what? We did see the northern lights when we were in Iceland. We did find out something, though. There's a correlation. This is science now. I only do science. There's a correlation. The first couple of nights, we didn't see the northern lights. There's a correlation between how much red wine you drink and the amount of northern lights you see. Now, I don't have the studies yet, but I'm working on that because it's about the science. More red wine, more northern lights. They became more distinct as we drank red wine. So red and the green of the northern lights has some sort of relationship. And then the more red wine I drank, the more teeth I saw. You know what I'm saying? Yeah, you know what I'm saying. Because look, is that not a tooth in there? Look at that. There's a tooth in there. Look at it. You see the molar? I'm going to point it out to you. And now it looks like it's head endo. See, it's right there. So again, there's a relationship between all this. Zirconia and lithium disilicate. In the world today, zirconia and lithium disilicate is all about 10 MDP. The adhesion is about 10 MDP. So back to that same old thing again. There's three groups of zirconia that we use today: anterior, posterior, and blended. Let's forget that. Let's just talk about zirconia as a group, if you will. Zirconia bonding is all about at 10 MDP. If you have contaminated surface on your zirconia, 10 MDP can't work. Let's say it like this. Blood has phosphates in it, and if phosphates are left on the inside of your crown after you try it in, then the phosphate group from the 10 MDP has nowhere to bond onto your zirconia because the phosphate space is already taken. Let me say it like this. In our world today, these are all zirconia crowns, no layering porcelain. Those are monolithic zirconia. When we try a crown in and take it out, you and I, most of the time, we just rinse our crown off, hand it to the assistant. The assistant puts some cement in there. We stick it on the tooth. If you want maximum bond to zirconia, you must get rid of contaminants on the inside. There's two basic ways to get rid of contaminants on the inside of your zirconia after you try it in. After you try it in, if you want maximum adhesion on that, you have to use a primer or a cleaner to get rid of the phosphates, or you can air abrade. Preferably, your lab has already air abraded the zirconia, and after you try it in, you can just put your cleaner on there. So if your dentistry is poor or your technique is sloppy, expect things to break like this. You can see where it was adjusted and the crown was too thin and it broke. It didn't matter what the cement or the technique was. Notice that the porcelain itself is a half a millimeter thick and the cement was a half a millimeter thick. That's even, but that's not good. Bridges that break and all that kind of stuff, you can be sloppy in your technique and things will fail. Don't do that. What I'm talking about now is that when you look at these cases, zirconia has failures associated with it for some of you more than others. Let's just get right down to what the research shows right now. Zirconia, 10% over 10% failed after 5 years. 12% came out within 5 years if cemented with a conventional cement, and that includes resin modified glass ionomers. 6.6 loosened with a self-adhesive resin cement without a primer. So let's just get to the chase here. Use for zirconia a self-adhesive dual cure resin cement, easy to clean up, that has 10 MDP in it. This is the thing. And if you want a maximum bond, make sure you get rid of the contaminants after you try it in. Here's the science. If the prep is good, almost any cement works. If you use a resin modified glass ionomer, it's probably going to be fine if your retention is built into the prep. Self-adhesive resin cements had significantly more success than traditional cements. So self-adhesive dual cure resin cements, SpeedSem, SmartSem, MaxSem, Unisem, TheraSem, those cements, especially if they had 10 MDP, have more clinical success than resin modified glass ionomers. Number 3, if your retention is poor and or you have a high parafunctional case, if the prep is poor or if the patient's a grinder and clencher, then you must bond to have good clinical success. Proper resin is critical, especially the more translucent your restoration is. So again, just giving you some ideas behind this, the 10 MDP is important. Cementation, there's thousands of cements. We've used, I swear, almost all of them on the market at this point. So we're looking for things that are easy to clean up, that we can use on both lithium disilicate and zirconia in the posterior. And just real simple for the staff, less materials, less things to find, less things to hide, less things to learn. But more importantly than anything, besides the 10 MDP, I want something that looks good, that's easy to clean up. And if it's therapeutic, that's an advantage, because all things being equal aesthetically and clinical characteristics wise, wouldn't it be better if our materials had a positive effect on the environment in the oral cavity? We want a positive effect. So we use cements, for instance, like TheraSem, that releases calcium and 10 MDP, dual cure resin based, and it is universal for zirconia and for lithium disilicate, those kinds of things. 10 MDP is what's important about this stuff. So again, you can find it in bonding agents, self-adhesive resin cements, and zirconia primers. As we get close to wrapping up here, if you have questions, please submit them, and we're going to answer those in just a minute here as we wrap up. So again, your 10 MDP is found in all kinds of different things. And if you want the best of all the worlds today, and that is therapeutic materials, bioactive, biofriendly materials that are also good, stable, long-term bonds with 10 MDP, then we look at materials that are regenerative in nature. Again, some of these materials have 10 MDP, some don't. When you try things in, you get contaminants on the surface. And just remember that if blood and the phosphates from your contaminants already are parked in the parking spot meant for phosphates, the 10 MDP has no place to work. So we've got to get rid of that stuff. How do you clean? Do you just rinse? Do you aerabrate, or do you use a cleaner? Most of the time, most of us just rinse. That is the honest to God's truth. And we rely on the retentiveness of our prep, because the 10 MDP is not going to bond to the zirconia. A lot of us some of us aerabrate, and we often get them back from the lab aerabrated. But after we try them in, if you want maximum adhesion, especially a parafunctional case or a compromised prep case, heck, that's all mine, then we want to use a cleaner first. Zirclean and Ivaclean, those kinds of cleaners remove the phosphate contaminants and other debris from the surface. After you try it in, you put some stuff, you put the Zirclean or Ivaclean in there and rinse it off. You're ready to go. put your 10 MDP containing cement in there, and you get the maximum longevity, and then you're set. So again, slow down, take that extra step, a few pennies, and these things are cheap, to use a cleaner and to clean, and that's it. So if the phosphates are in the way, then you can't bond to the tooth. So as we wrap up here, I'm going to just summarize by saying this: more clinical success, less stress, slow down and enjoy the ride. Make sure that you know what materials you're using. Acidity and the contents, I think, are real important. I think you ought to know that, because heck, Follow the Science is all over on the news channels. I think that we ought to at least be following it in our practice. And I want to thank you for your time. I want to thank Bisco, Viva Learning, and I want to thank all those in military service or in harm's way these days. Some weird things happening, and I just want to let you all know that time is precious, and I want you to learn to enjoy it. Can you please talk about deep caries and bonding? The deeper the decay, the less chance that we have of having a good bond. The deeper the decay that we have, the more likely I am to use a therapeutic liner over the decay, like Theracal or something like that. And then I do my selective etch and my bonding agent over that liner. Feeling about 2 coats of Gluma. I have no problem with Gluma. Gluma is a antimicrobial, but more importantly, in the bonding world, it has a wetting agent called HEMA in it. So Gluma is fine. Now, we don't do that, and I haven't done that in many years. Do I think it's necessary? I don't. Is it an extra step that might help you a little bit? It could, because it is antimicrobial and it is a wetting agent. So after you etch, apply it, and then apply your bonding agent. That is prudent for some people. I just don't do it. Can you use Fuji Plus with zirconia? Fuji Plus is fine. I just would, to me, a dual Kurosawa adhesive resin cement is backed by so much science. I would be afraid to go back to using any kind of resin modified glass ionomer. Please show the molecular structure of the phosphate. Okay, you Google that. Google that. Thank you all very much for your time, and safe journeys to you all. Good luck to you.